Okay, so welcome to another video in the 3D print tutorial sequence. In this one we're going to cover geometric type C, which is the aggregation. And I just want to point out again, with each one of these you'll want to choose one of these two kind of bounding box formats, either the 2x2x2 cube or the 3x3x1 kind of tile there. So I am going to go over to Rhino. First thing I want to do always is check my units. I want to be working in inches. And then I'll expand my top view here. And I'm going to go ahead and make that bounding box first. So for this one, I'm going to use the cube as well. So for just use the command box to draw a box. I'm going to choose as my starting point 0, 0, and press enter. And then I'll enter the dimensions of my box, 2 by 2 by 2. So again, hold Control Shift and right click and drag on the keyboard to orbit in an orthogonal view. Select an object and type zoom and hit the option selected or type S, enter, to set an object to the center of your orbit when you're orbiting in 3D. I'm going to go ahead and start working here in ghosted. Also, if you want to adjust the transparency of your kind of viewport in ghosted, open up the display properties panel by typing in display properties. And then down here, if you're in ghosted already, you can set the kind of transparency of your viewport by changing that number next to transparency. So the higher the number, the more kind of transparent your geometry will be. I'm going to set this layer to my bounding box. Go ahead and set another layer as current and lock that first one. And I'm going to walk you through the kind of basic techniques for this type of geometry, the aggregation. And an aggregation is called that because basically it's a collection of smaller geometries. So for example, if you imagine, we could work by like dividing this cube up into smaller dimensions. Let's say we did a 1/4 inch by 1/4 inch. That's quite small. Maybe I'll go 1/2 inch. And if you look at the examples, so that first example there is kind of following in this type of geometry. And so what I would actually do is just work by making a kind of solid collection of these shapes. I'm just copying row to kind of layer, and there we go. Now I could turn off my bounding box too. Then I would just work by kind of trying different ways to subtract from the cube there. And I think what the kind of potential of this type of geometry is that you can kind of interlock it in interesting ways. So what I mean by that is, for example, if I were to print this shape, and I'll just group it real quick too, so I don't get too messy here. We're looking at kind of different ways that these shapes, or this shape, can interlock with itself, right? So I think the more you kind of try this basically, and just play around with how this shape can like aggregate. I think that would be the best kind of test for how well your kind of shape is going to perform as a kind of aggregation module. So I think there's a lot of ways you could divide it. I also want to point out there's a lot of ways, or there's a lot of types of shapes you can use here, and kind of collections of shapes. So again, we can use the box. We can go maybe 1 inch by 1/2 inch. You know, and then we can kind of change the grain of it. So the point is you can use a lot of different kind of collections of shapes. You know, and kind of play around with what those interlocking patterns could be. And once again, I recommend you kind of test just by playing around with some of the configurations that you can make with it. You know, and just kind of see what you can come up with there. And I just want to point out that once you're done and you're kind of happy with whatever shape you're using, what you want to do is make sure that you have one kind of solid. So again, I'm going to ungroup this now. You know, these are still ungroup. These are still individual little boxes here. If I wanted to make this one solid closed object, I basically need to join them together. And in order to do that, I'm going to use the Boolean union. So again, in order to use a Boolean operation, you need a closed solid geometry. And I would recommend you kind of go one by one. If you try and do them all at the same time, it may fail on you. I would just kind of go piecemeal. And what you do want to avoid is like making a, skipping a geometry. So it would work your way from one side of your shape to the other as you go. And then I think the other thing that is good to pay attention to is going to be, like what orientation makes sense, again, for 3D printing. So with this geometry, I kind of, by definition, am going to need support in order to print it, right? So there's a couple different ways I could deal with that. But no matter what, I'm going to have overhangs. Like no matter what orientation I put it in, I'm going to have some kind of overhang, which means that I'm going to need some support, in order to 3D print it. So that's just another thing to consider. With each one of your iterations, try and put it in a few different orientations, and just see how printable it is, and that may be worthwhile making a geometry that's a bit simpler to print in order to save time. Okay, so that should conclude this geometric type. Again, once you're ready with one of your geometries, you'll be able to, or you'll want to continue on to the final tutorial, which will show you how to set up the geometry for the 3D printing and then send it to the to Maker Fleet. Right, so I will send